Okay, Algebra 2, this is your new topic for today. It's quadratics. It's actually a new unit, so go ahead and put unit, or number 3, I'm sorry, quadratics, and subunit parent slash transformations, number 9, and this is going to be in vertex form. Okay, this is actually the second redo of this video because I wasn't happy with the first one. But here's the title. Go ahead and copy that down, please. Okay, this is just a quick view of what your paper is going to look like. You do need 2 pages for this. I would recommend you do it this way. If you do not have this page available on the left, I would actually skip a page and just go ahead and use both pages because you're going to be using this little piece of paper as reference for your notes and for your assignment, okay? So go ahead and just set up your book like this, please. Here's the title. Go ahead and copy that down. Okay, so it's parent slash transformations, number 9, and you are going to copy quite a bit right here underneath. I'll give you some time for that. Okay, so this is actually our parent function for quadratics. It's y equals x squared, and a lot of you actually should remember this from last year. If you don't, that's all right. You know, we'll go over it. The new word in here is actually concavity. So if you're not sure what it means, not a big deal. I will explain it briefly. The first thing we're going to do is graph y equals x squared without a calculator. Looks like this, kind of a U-shaped graph. We call it a parabola. This one is facing upward and it has 2 arrows, which mean that it's going forever up this way, forever up this way, forever left, and forever right. So that should kind of give you an idea on the domain and range. The domain for any parabola that's not associated with any kind of word problem or application is always going to be all real numbers. Okay, and I actually wrote 2 things here. The domain is all real numbers. I put the fancy R. And then the range for this problem actually starts here at 0 and it goes up, therefore it's greater than or equal to 0. Okay, this is algebraic notation. This one over here is in interval notation, but they're the same thing. So you can use either one. I'm going to go ahead and just, this one is algebraic, this one is interval. You can use whichever one you want. If you want to use set notation, you can also use that one. That's the one with the squigglies, the extra y, and the line. I'm not going to do that one though because there's not that much room here. Okay. The vertex for this, okay, you can see that I highlighted the bottom point here because that's like your halfway point sort of. And this point is 0, 0. So my vertex is just 0, 0. And most of you should remember that this is actually a minimum point, okay, which is this part right here. For today, we're not going to actually find the minimum point. All we're going to do is identify if it's a minimum or a maximum, which is, you know, pretty simple just by looking at it. The concavity for this one. Let me tell you what concavity means. Concavity refers to whether the parabola is facing upward or it's facing downward. Okay, this one is actually going up because the arrows are facing up. So the concavity for this one is just up. Okay, and if the concavity is up, then we're going to have a minimum. And a minimum is just the lowest point on the graph. We can't say it's a maximum because the arrows indicate that it's going forever up. So it doesn't really have a maximum point. It just goes on forever. It does have a minimum though, and that's why we say this one has a minimum. If you have any questions, please let me know. Okay, I'm going to go a little bit faster in this redo because the other one was just way too long. Okay, first example. Actually, we're going to look at a few things first. Okay, so on this little paper that you stapled in, go ahead and copy the following things. Vertex form, and then vertex at the bottom with your negative HK. And if you have colors, by all means, color code. All my A's are one color, my H's are another, my K's are another. And notice that my vertex, I just highlighted. I have it here and here because that's what the vertex was referring to. So I'll go ahead and give you some time if you want to classify this stuff. Okay, and I'm just going to go over this very briefly. What you're going to be doing in today's assignment and in these examples is identifying your A, your H, and your K and what they do to the graph. Okay, remember all of our graphs are based off of the parent graph, x squared, y equals x squared. So when we talk about it moves to the right or it moves to the left or up or down, we're talking about from the origin 0, 0. Okay, a few things here that I do want you to take note of. If a is negative, this one right here, that means that your graph is going to be reflected over the x-axis, and you have this on your paper, so you can just use that as reference. That means it's going to be downward like this, okay? If a is positive, well, obviously it's going to be the opposite. It's going to be upward. So, like that, okay? Just a quick reference. These two things in here are kind of new. We'll talk about that when we get to the example. One of the main things I do want you to notice is this part right here. This right here, it's always going to be opposite. And I'm just going to put OPP for opposite. Notice that negative H means right. Positive H means left. These are always weird because they have to do with X, and you'll see that in the examples. Okay, so I'm going to go ahead and go to the first example and show you how we apply these. So go ahead and copy this down, please, into your notebook. Okay, just like before, copy this down, ignore this. This is not part of it. Okay, so I went ahead and underlined the first number here, which is -5, and I did label this as A because this is in the position of A. Again, we're referencing A, H, and K from that little paper that you have. Okay, you have it in your notebook. Since it's negative, it tells me that if A is negative, it's going to reflect over the x-axis. And right away, that should tell some of us that that means that my graph is going to be downward, because reflection means that the graph flips from upward to downward. Okay. Also, we have a 5. Since 5 is greater than 1, that means we're going to have a vertical stretch by 5. And again, this is in your little paper. Just look at A, and it says A greater than 1, vertical stretch. So we write vertical stretch by whatever number this is. Okay. We also labeled H and we labeled K. So in the next slide, I'm going to show you how to do that. Okay, go ahead and copy this down. Okay, so my H in this one is +3. If you look at your reference sheet up here, it says that plus H means left. So +3 actually means 3 units to the left. The K is this exactly as you see it. K has to do with your Y value, so this means 1 unit down. And you'll get used to this. We actually see this the entire year transformations. So if you don't get it today, trust me, you'll have this down by the end of the semester. Sorry about that. That was the intercom again. Have to make these at different times, I guess. But anyway, so we're almost done with this. We're just going to go ahead and do the vertex. And there it is. Notice that I highlighted my H and my K. H is always going to be the opposite. So instead of +3, it's -3. K is the exact same. So -1, -1. And this vertex actually tells us where we're going to start our graph. Okay, so please ask questions if you have them. I'm going to go ahead and go to the next slide if you have none. Okay, so I went ahead and drew a graph right next to it, just so we can plot our, or sketch our graph, I should say, this graph right here. Okay, we're going to start with the vertex. Go ahead and copy this stuff down. Okay, so notice that we have our vertex at -3, -1. It is downward because of that reflection. Okay, I even wrote concave down. This is concave down. And since it's concave down, this is a maximum. So you can just write max. Okay. For the domain, hopefully you remember that the domain for any parabola is just going to be all real numbers. Okay. The range for this one. Now there's kind of a trick for this piece right here. I'm gonna rewrite my equation. You don't have to. You have it on your paper. I don't want to be going back and forth. So our equation was -5, and then it was x +3. Bear with me. Hang on a sec. Okay, so this was our equation, and you have it already. You have it right here. So don't copy it over. Okay, and a trick for the range: if your graph is going downward, like it is here because of the negative here, then my range is going to have to do something with this. It's always going to be with this number here, but because it's downward, then range is just going to be less than that number. So in this case, y is less than or equal to -1. Okay, just a small little trick. And if you don't want to use it, that's fine. Just by looking at the graph, you can see that it's going from negative infinity, so negative infinity, all the way to -1. So you can also write it that way. You can use interval notation like this, negative infinity to -1. And either one is fine, whatever you're more comfortable with, okay? And that's pretty much all you're going to find for this. So if you have any questions, let me know. I'm going to do one more example. Go ahead and copy that down, please. Okay, on this one, I'm going to go a little bit faster. Here is our two things. We have our A. This time there's no negative, so we have no reflection. But we do have a fraction, though. And if you look at your notes up there, a fraction is the one that falls between 0 and 1. Something like this. 0 less than A less than 1. Okay, this is considered a fraction. So 1/2 would be a vertical compression by well, whatever that number is. Then we have our h, which is -2. Minus h is the opposite, so it's 2 units to the right. And finally, we have +3, which is just, well, 3 units up. Okay, I'm going too fast. Please stop me. This example is more of an extra. Okay, but we're going to find our vertex now, which is the last part. Just like before, if it helps, highlights or circle these numbers here, this number and this number, because this is our vertex. The only difference is this one has to be the opposite. So instead of -2, it's +2. This one, the exact same. Okay, opposite same, opposite same. That's what you should be thinking. And just really quickly, since there's no negative in the front, that should tell us that our A is positive, so the parabola is just going to go upward. Okay, so final slide. Here's a graph, and you're just going to graph this parabola. So it's 2, 3. Copy that down, please. Okay, so there's my graph 2, 3. And because this one is going upward, I went ahead and wrote up. The concavity is up. And since it's upward, it's a minimum because it's the lowest point on the graph. Okay, for your description for this, because you do have that in your paper, the descriptions, guys, are just what we wrote up here. 2 to the left, 2 to the right, I'm sorry, 3 up, vertical compression. And since it's a vertical compression, notice that my parabola is kind of wider. If you don't get that part, that's okay. We're going to deal with that a little bit more later. But compression just means that the graph kind of got squashed. Stretch means the graph kind of got pulled up. Okay, so that's it for that. And I think that might be it. Oh, and the domain and range, go ahead and copy that down. Okay, so just like before, the domain is always, always all real numbers. The range for this one, it's going to be anything bigger than 3 because the graph starts at 3 and it goes up. So this time it's greater than or equal to 3. And of course, you can write interval notation instead if you would prefer. Okay, so if you don't have any questions, go ahead and get started. And that's it for this video.